Hi, I'm David. Let's try to make a rocket land. So as a disclaimer, this is not affiliated with SpaceX. It is a final project for undergraduate at class taught at MIT. So skydiving is basically what Starship does here, right? I mean, it can do belly flop, it does a flip up, it is using its arms and legs and flaps. This is amazing. So let's try to build it in Drake. For that, I've modeled it in SolidWorks with approximately the same inertia. It's 15 meters long, 85,000 kilograms heavy, and we could import that to a URDF file using here, but then we have to add like some aerodynamic forces. For the flaps, I was using the flat plate model that we've seen in the protein example, which behaves really well under like stall conditions, which is exactly what we want here for Starship. And similarly, to make a successful belly flop, we need drag on the body itself. And for that, we just take the spatial velocity, we put transformer to the body frame at the center of pressure and take the individual components along the longitudinal and transverse direction and compute the drag there. So, let's start with some simple things. We can use direct transcription to do things like yawing. So on the left-hand side, there was a top view where like Starship is basically pushing the diagonal flaps to move air. This is not exactly how we as skydivers turn, but Starship can turn like that. It's amazing. One of the first things that I've learned was doing a barrel roll. Okay, mine is pretty shitty. So yeah, so Starship does a pretty decent barrel roll, which can be used for barbecuing. Basically, when you're re-entering, you would do the barrel roll so that you would heat like on all the surfaces equivalently. But what really bothered me that like Starship was using the thrusters to flip up. We can do without actually. So direct transcription was finding a solution here. But out of curiosity, I used a finite horizon linear quadratic regulator and found that flapping would stabilize the upright position really well. But with some slight disturbances in wind, you would see it would go crazy and not be able to control it. I guess like that is why they do use thrusters in the end. But yeah, let's try to make land. Here we use transcription again, and as you can see, the left-hand side is the body frame. We can land that bird. Yeah, it works. So I guess like for the future, I think we can add, the cool thing about the optimization is we can just add other thermodynamic constraints, maybe do G-force constraints for humans, have adaptive aerodynamic models, include a catcher or drone ship to get the rocket, or even do like water landings like actual birds. Yeah, feel free to check out my code.